Hello and welcome to our next geometry lesson. So this one's going to be on regular polygons. So just like all the other lessons, you will need your maths book, pen and calculator. So if you don't have those things yet, make sure you pause the video, collect your equipment, and then come back to resume. All right, so hopefully we're all ready. First thing is, this lesson's going to be just focused on regular polygons. What is a regular polygon? Well, here are our notes on it. It's just a polygon whose angles are all equal and sides are all equal. So pause the video here. Make sure you get your heading and your first note in for today, and then we'll continue on with the lesson. All right, so what kind of makes the regular polygons a little bit easier than what we've been doing in the past is because all the angles are equal, it's actually going to make a lot of our calculations a lot easier for this lesson than they have been in the past. But firstly, let's have a look at a few cases of some regular polygons. The first one up here, here it is a regular triangle. Firstly, it's a triangle. It's got three sides. We're fine with that. What makes it regular is all three sides are the same length, and because of that, all three angles will also be the same size. This regular triangle actually has a special name. You may remember from year 7, this is what we call the equilateral triangle. But again, that's just a name for what is a regular triangle. The next one beneath that is a quadrilateral. Now this is the regular quadrilateral because we can see all sides are the same, all angles will be the same. And if you're curious and you're wondering, well, how do we know all sides are the same? They look the same, but how do we know that they're the same? Again, the clue is in this dash. This side here has a single dash. That means any other side that also has a single dash will also be the same length as it. So in this case, you can clearly see all four sides are the same length here, making this a regular quadrilateral. And again, this particular quadrilateral also has a special name, and we all know its special name is a square. And just for illustration purposes, here's a regular pentagon drawn over this side as well. I don't know if it has a special name. If it does, I'm unaware of it. But anyway, there's a regular pentagon. All sides will be the same, and all of these angles will also be of the exact same size. Again, that's going to allow us to shortcut a lot of our calculations. So let's move on to the first of our examples. So we're going to determine the size of the angle theta. Here we can see it right here. Here's the angle we're trying to find the size of. Now, with these questions, if you're trying to find the size of an angle of a regular polygon, firstly, you're going to need to know the angle sum. Fortunately, this is the triangle, right? We know what the angle sum of a triangle is. It's 180. So the angle sum is 180 degrees. Here, I'll even write that in if you want. The angle sum is 180 degrees. Now, if you want to find the size of this angle theta here, well, what makes these regular polygons so easy is all of the angles are equal. So if you want to find the size of one of them, all you need to do is take the angle sum and just divide it by how many angles there are, which is 3. Right, we're splitting that angle sum between the 3 different angles, and you end up getting the size of that angle. It's 60 degrees, and funnily enough, because it's regular, all the angles will be 60 degrees. And here you can see 60 plus 60 plus 60, it ends up giving you the 180 degree angle sum. But this is a process we do to determine the size of any regular polygon. So it's pretty simple. Let's look at, I guess before we move on to the next example, definitely make sure you get this first example in your books. So pause the video if you need to, and then resume play for the next example once you're ready. Okay, so example 2. All right, so I got a little bit lazy here, but the same sort of question. We're going to calculate the size of this angle that's been marked theta. It's just one of the random angles in this octagon. I could have put the theta at any angle, to be perfectly honest, because as we've learnt today, it's a regular octagon. Every single angle here will be the same size. We just need to find the size of those angles. So, just like in the first example, our first step is to work out what do all the angles add up to, right? What's our angle sum? Well, we've got the method for that, right? This polygon here has 8 sides, so we're going to use that rule of taking away 2. So it'll be 6 lots of 180. And if you've forgotten why it is we're doing that, it's because an octagon, if you broke it up, it would end up forming 1, 2, 3, 4, 5, 6 triangles. So if you want to find the angle sum of an 8-sided shape, take away 2, it'll be 6 lots of 180. That's what we type into our calculator. You'll end up getting 1080 degrees. So that's what our 8 angles add up to. So we've got our angle sum. There's our first mark. Things are going great. Now to find the size of one of those angles, theta, again, just like we did in the first example, all of the angles add up to 1080 degrees. All the angles are equal. So to find the size of just one of them, we can just divide the angle sum by the number of angles, which ends up being 8. So we just type this in our calculator, we press equals, we end up getting a number, and that's it with the question. We've now found the size of, well, not only this angle, but every single interior angle in this octagon. All right, our final example for today. So this one here, it's exactly the same. It's just they haven't given us the diagram this time. They want us to calculate the interior angle of a regular decagon. Now, by interior angle, if you're a little bit confused about what that means, it just means the angle inside. So here in the second example, we found the interior angle. Same as the first one, that 60 degrees was the interior angle of that triangle. So this question really is asking us to do the same thing as what we've just done, except now we're trying to find the interior angle of a regular decagon. So what's our first step? A decagon has 10 angles. What's going to be the angle sum? So using our rule, we're going to take away 2 from 10. So the angle sum will just be 8 lots of 180. Type this in your calculator. You've got the angle sum and the first mark in the question. Now that we know what all of the angles add up to, we can then find the size of one of these interior angles, which I'm just going to call theta because that's what we've been doing. So all the angles add up to 1440. There are 10 angles in total. So let's divide it by 10 to split it up. Every single one of those interior angles will be the size 144 degrees. As easy as that. They don't really get any harder. It's just the same sort of thing. Calculate the angle sum. Once you've done that, you can then find your interior angle by dividing your angle sum by the number of angles. And that's it with our 3 examples. So again, just like the others, make sure you copy our third example in. If you didn't do that for the second one, make sure you get example number 2 in as well. You won't need to copy in that. That was just to illustrate, but make sure you've got that example in, this one. Once all your examples are in, you're ready to move on to your own questions so we can finish off this lesson. All right, so your questions for this lesson, just like what we've been doing, I'm going to get you to find the interior angle for each of the following regular polygons. So we've got a pentagon, which has 5 sides, right? The hexagon, which has 6. The heptagon has 7. And the nonagon has 9 sides. So just do what we've just done for these 4 shapes here. Don't be alarmed if one of the answers ends up being a decimal. If that's the case, you're actually doing it correct. The other 3 should be whole numbers. So pause the video, have a go at coming up with your solutions, and once you've got your answers ready, press play again so you can check your solutions. All right, so hopefully everyone's had a go at answering these questions. Now, onto the solutions. So you should have ended up with 108 degrees for the first one. You should have had 540 for the angle sum, by the way. The second was 120 degrees. The third one was the one that was a decimal. It ended up being 128.57, etc. If you wanted to just round it to the nearest degree, I think that's totally reasonable. And that's what I ended up doing here. And the final one, you should have had 140 degrees. All right, so hopefully everyone had some success. If you do have any questions or queries, feel free to leave a comment here on YouTube, back on Canvas, or you can email me directly. Best of luck with your geometry, guys. All right, bye.